Okay, so hi everyone. Sorry for being late. We had a technical difficulty with the audio. Uh, there's a joke about how do you know that Star Trek is a science fiction, and that's because when two ships meet, the video just works. Um, and I guess we're not in that point in the future yet, so you'll have to forgive us. My name is Miki, and we're going to talk about JSON, the fine print, and I want to make sure that you can see my slides, and we are going to start. All right. Thank you, Eric. So, because we're short on time, I am Miki Tebeka. I'm a developer for 27 years now. Been doing a lot of things from writing books to writing software. I do write code on a daily basis to customers and open source. And with that, I do a lot of serialization, really too much. So we're going to talk about one format of serialization, which is JSON, and we're going to look a little bit about serialization in general, and then dive into the details of JSON and specifically how do you work with JSON with Go. So let's start by just talking about serialization and why do we need it. So serialization is taking a data structure in your language, say a slice or maybe a map, but it can even be a string or an integer, and you convert it to a sequence of bytes and then back. The question is why do we need it at all? And the answer is that under the hood, when you look at the hardware doesn't understand any concept of data structures. It just bits and bytes all over the hardware. So every time that you need to pass data from one place to another, you are going to look at bytes and you're going to convert these bytes back and forth from your program and back. And serialization, the idea sounds really simple, right? Take an integer, make it a sequence of bytes and then back. But it can get really tricky and some things are really complicated. The example you see right now on the slide is a serialization of the string serialization with these bigger than and smaller than signs to a sequence of bytes. And this format of serialization is known as UTF-8 encoding. And we're not going to go into Unicode, that's a whole new talk. But if you're dealing with Unicode, you probably know it's not easy. So serialization can be really tricky with format where you put the bytes. You want things to be fast and efficient. So there are many considerations. So before we dive in specifically to JSON, I'd like to talk about some mistakes that people do when dealing with serialization. So if you look at the slide, we have the common three layers that we say on of a program. Right, we have the API layer, the one that communicates with the clients. They can be REST clients, they can be maybe some kind of UI and other things. Then you have the business layer. The business layer is the one that actually doing the work. All the smarts is going in the business layer. And down below the business layer, we have the storage layer. This is where we store data and keep it for later. Usually it's a database, but Parquet files, you name it. There are many, many ways to keep data in storage. And the first mistake is that serialization should be only at the edges of your program. So when the API layer talks to someone on the outside, and the storage layer is keeping data. This is where you do serialization. And writing to a database, it is a serialization action, right? We have the integer in Go, and we have the integer in, let's say, Postgres SQL. That's a different integer. Can be, not necessarily. And we need to convert them back and forth. So the mistake is that you continue to do serialization even you talk between the API and the business layer and the business layer and the storage layer. In these places, you should be talking only in native time. So for example, let's say in the API layer, you got this some kind of a timestamp, and it comes in as a string. What you should do in your API layer is convert this string to Go time to time And then between the API and the business, and between the business and storage, always use the native type of time to time. And don't do every time pass a string and then someone needs to do this serialization from the string to the time. This is redundant. And when we talk about performance, this is really heavy on performance. I spend a fair amount of time optimizing services for clients, and this is a common mistake that I see. They just repassing the same time string again and again and again in every function call. This is very bad. So only on the outside layers, only on the ones that are connected to the outside world, let's say, you need to do serialization. Once you are in the same memory space, right? So the same process, go teams share the same memory space. There's no need for serialization. You can pass native types. It's going to be faster, more efficient, and you will get type safety, which is another big plus. So this is the first mistake that we can see. The second mistake is that people are using the same types throughout these three layers. So let's say I have a user and I have the same user for the business layer, the storage layer, and the API layer. And at the beginning, right, they are going to look the same. Maybe just a login and a name, maybe some permissions, but that's it. But the thing is, now you're tying these layers all together. So if you think about developing something with a document-based database, such as MongoDB or maybe Elasticsearch, it's really easy to say, the client asked me for a document, it gave me an ID, I go to the database, gets this document by ID and just push it out to the user all the way. Very little amount of work on my side. But you're tying all of these layers together, and there are several issues with it. One is someone makes a change to the storage layer. Maybe they rename the fields. Maybe they added some kind of fields that you don't want to go out. Maybe there's the user address on the user in the storage layer, and you don't want that because a regulation like GDPR and other things. So you need to be careful about what you're sending out. And the second issue is that if you look on the left side, each of these layers have a different velocity of development. The amount of changes per time is really different. Your API layer, it should be really, really stable, right? You know that every time you change something in the API, all the users gets angry. So API layers are usually very stable until you do a major change like V2 or V3, but that's a big effort. So the API layer, once you think about it, usually keeps stable. The business layer is the one that has the highest development velocity. You add rules, you add features, you add other things. So this is going to change. And data structures are going to change much faster in the user layer, in the business layer, sorry, versus the API layer. And finally, we have the storage layer. I would say this is a medium velocity. Most of the time, it's pretty stable, but we add a column to a table, or maybe add a field to something else. So this is a different velocity. And if you keep the same user structure throughout these layers, there's going to be some tension between the business layer want to change and add things, the API layer want to keep it really, really simple and the same. So I recommend having one type of user per each layer. And at the beginning of a project, this is going to look redundant, but it's going to pay off in the future when you start seeing changes. And also, every time you see someone going through a lot of hoops in the API layer, passing what the user is sending and trying to match it to some kind of a struct that the business layer is using, this is a good sign that there's no separation and you're tying these layers together. So this is mistake number two. And the last mistake is that assuming that once we have a valid JSON or valid serialization in any way, like it can be XML or YAML or whatever, this is valid data. And this is not true, right? We have a very simple message that contains latitude and longitude. And this is valid JSON. If you run it through a JSON, this is fine. But the problem is that longitudes can go up to 180, no more than that. And here we have 192. So every time you get some data, you have to validate it. And I see people scheming that all the time. because validation it's a tough issue. It's really hard to validate data, to make sure that your assumptions on the data are good and that everything is working. But it's well worth the investment. So don't assume that just because the user sends you a valid JSON, the request that you're sending is valid. You need to validate again and again. There are libraries that you can use to validate, but I tend to do it manually. I just write a validate function, and then I write all my assumptions in code. I found out that all of these libraries, there's the one from the playground, they're giving me a lot of benefit, but they're usually missing something, especially if I have codependencies between two fields. Let's say I have a person height and a person weight. I can't have a very, very tall person weighing only very little. So sometimes I even have some dependencies between two fields that I need to do validation, and most of these frameworks don't see. Okay, so now we're going to talk about JSON specifically. JSON is a schemaless, meaning it does not have a schema. Every time you get a message, there can be a different set of fields, and every field can have a different type anytime you want. And it is a textual serialization format, meaning we as humans can read it. It has a nice advantage that you can view data at transit. You can look at a response from an HTTP server. You just understand what's going on. This is great, but we pay a price. So the price we pay is that there is more bytes on the wire when we use this kind of serialization format. If you look at, let's say, binary formats, let's say protocol buffers, from my experience, protocol buffers is between a third and fourth of the size of the same JSON message. And since we pay by bandwidth, this is money. But the big advantage of JSON is that almost every language speaks it, right? So once you do JSON, including the browser, right? JSON, JavaScript, object notation, it comes from JavaScript, it can work with it. Now JSON have specific types, right? So the passenger count here is 3. This is a number. And then we have car ID, which is a string. We have tags, which can be, it's a list in JSON. We have booleans, we have null. But these are the types that JSON defines, and we'll talk about them. Some types are missing, right? So we have the types that the format define, the JSON formats define, and we have the types in Go. And in Go, for example, we have a time to time. In databases, it's known as a timestamp. In Python, it's a datetime. Every language has it. In JSON, there's no such thing. So you see that the start time on the message is actually a string. And now I need some external knowledge about the message saying, hey, this comes in as a string, but you should actually convert it into a time to time. And this is what I talk about schemaless also, that there's no schema. I don't know. I need to know from the outside what are the expected types for that. And there's something like JSON schema and other things, but it's not built in the format. Right, and schema again, schemaless lets you move fast, but in the long run, having no schema is usually a recipe for error. Okay, so what are the types? In JSON, we have these 3 types that are defined, 6 types, sorry, not 3, 6, that are defined by JSON. So we have a string type, and this is mapped to a Go string. This is easy, right? Until you find out that JSON in a field that is usually a string can have a null, which is great, but there's no null strings in Go. We have just the empty string. A string cannot be nil. This is not something that we have. So even this simple mapping can be problematic. In JSON, we have a single type of number, and that's it. We don't have any more numbers. In Go, we have 9, 10 type of numbers, right? We have the 2 kind of floats. We have 4 kinds of ints twice. So this is 10. We have also 2 complex numbers, so actually 12 kind of numbers. And the question is, what are we going to do, right? We got a number from JSON. How do we know the type that is going to be? And if you're using a struct, then Go is aware of the field type and it will try to do it. But if you don't say anything, if you just give it any, then Go is going to use float 64 for that. We have booleans that goes to Go boolean type. We have null, nothing, which goes nil. And as I said, it is problematic because in JSON anything can be null, but in Go no. And then we have arrays in JSON. Arrays are a sequence of things, um, and either it's some kind of type in Go, right? Natively, we can have a slice of only integers or slice of only strings. We cannot have a slice with integers and strings both inside the same thing. And in JSON, this is pretty popular. In case that we actually do have different types in the same JSON array, we are going to use a slice of any, which can contain these types. But now working with that is really, really hard, or not hard, but really annoying, right? Because we need to do type assertions all the time to move it to the right. And the last thing we have in JSON is an object. This is the thing with the curly braces that we used to see. And in Go, we either map it to a struct, which is what we usually do, or we can map it also to a map, and this is map of strings. So the strings are the name of the fields in JSON, or the members in JSON, and the any, meaning it can be anything. And working with map from string to any, it can be really frustrating, especially if you have nested JSON objects and then you need to take one of them and convert that also to a map of string of any and continue there. This is not really fun. So we prefer to work with structs, and we'll see that later. Two things that are missing. I talked about time.time. This is missing. The JSON encoder and decoder by default convert and read time in RFC 3339 format. We have the example there. So if you have a struct with a time field, Go is going to serialize it to JSON as a string. But if someone else, let's say Python code, is consuming that, they need to know that this is a string, but actually this should be a time, and this is the format I need it to convert it. There's a question, does Go want us to avoid an array of mixed types? Yes, this is not just Go. Most languages, most statically typed languages, they don't like mixed types. You can do it with with the slice of any. It is possible, but you're bypassing the type system and you need to do type assertions, which is not usually fun. And the second thing that is missing from JSON is binary things, right? We don't have a binary in databases. We have blobs. In Go, we have this byte slice, right? Which can be an image or anything else might be binary. The Go decoder and encoder also handle that. What they do is they convert this binary type to a string in what is known as a base 64 encoding. Base 64, been around for a long, long time, comes from email. An email, when you add an attachment, actually being converted to a base 64 and then being sent, because email is also a textual format. So for example, the string Go is going to be encoded to the string R28 and equals sign. That is going to be. But again, here, the other side need to know that this is what Go is doing. So if I'm sending from Go to Java, Java says, okay, I got a string, but now I need to use base 64 to convert it back to, let's say, an image, if I need to work with that image. So this is the type conversions that we have between JSON and Go. And most of the time it works really well. Other types are not supported, right? So if you have your own types that are not structs, maybe a linked list and other things, Go is going to convert them, but it's usually not going to do what you think it should be doing. And we'll talk a little bit later on about how you can say, this is the type and I want you to serialize it as something. Question about blobs. So JSON, I said JSON, the format does not have binary types. So if I want to pass, let's say, user with the icon of the user to someone to display, I cannot send the icon, which is an image, as a binary thing. I need to convert it somehow to a string and then move it on. And this is what Go is doing with this. Okay, so the library that we have is in the standard library. It is called encoding JSON, and it has an ability to work with bytes or with what we call files in Go or readers and writers. So if you go from JSON to Go and what you have is basically a sequence of bytes, then you are going to use the JSON.unmarshal. And if you have bytes in Go and you want to convert them to JSON, you're going to use JSON.marshal. If you have a reader, for example, an HTTP request body or maybe an open file, and you want to read JSON from it, now you're going to use the decoder, or to create one, you're going to use JSON.new decoder. And if you want to write JSON, let's say to an HTTP response or maybe to a file, again, you're going to use the new encoder this time. Now, the encoding JSON has some, is very relaxed in the way that it handles decoding and encoding. So if you have an incoming message and you want to save it or you want to decode it into a struct, if there is some member of the JSON object that is not found in the struct, the encoding JSON is not going to fail or return an error, it's just going to ignore it. And the other way as well. If I have something in a struct that is not found in the JSON, the Go encoder is not going to do anything for that. Right, and this is going to cause us a problem. We're going to talk about it later about zero versus missing value. But basically, unknown fields and unknown members, the Go encoding JSON just ignores them. It's not going to be in there. Because in Go, you have to work with exported symbols or exported fields in your struct. Encoding Go has some assumptions about how to match names in JSON that are usually lowercase to exported symbols that start with an uppercase. So if I have a struct with a field called name with start with an uppercase N, and in the JSON there's going to be name all lowercase, encoding.json knows how to do the match and actually fill the name in Go that start with a capital letter from the lowercase name that there is. Right? So let's say that I have a like. Think about social network. Someone clicked a like on some kind of a post. So the struct itself has a post ID and then the login of the user that clicked on the like. So I'm creating a request. And now I'm using this bytes API where I'm going to use JSON.marshal, and now data is actually a sequence of bytes. And now I can do whatever I want with these bytes, write them, send over the network, store them in the database. That's up to me. But this is just working with bytes. And this is encoding, or as we call it, marshalling. When we do decoding or unmarshalling, here I'm choosing the other side of things. So I'm going to work with an IO reader. So I'm wrapping this data with the bytes.buffer. Now I'm creating a decoder on the buffer. And then I'm using decode on a new like, and I'm going to print it out. If I'm going to run the code, you see that I'm getting back the same thing that I sent, right? So I marshal to JSON, and I unmarshal back, and this is coming like this. Now, let's say that the name matching is not that straightforward. Right, so I have an event with a user ID, but in the JSON, it's user underscore ID. And now if you are going to do the unmarshalling of this data into an event, you're going to see that the user ID is actually 0. This is the 0 value, right? Go is initializing every field in a struct to its 0 value. But the action, because this is actually in lowercase and this is actually in uppercase, there is a matching between them. So we are missing that. Um, there is a comment about unmarshal that it's not suitable for large data sets or streams because it may require a lot of memory. Right. So in general, if someone sends you a really large JSON, that's a problem. Try not to have that, and we'll talk about options about how to stream JSONs instead of creating a really, really large one by yourself. Okay, so the solution for this one is something known as a field tag. I can add this thing next to the user ID, and this is known as a field tag. It's not necessarily just for JSON. You are going to see it also in, let's say, ORMs or in YAML. Each of them has its own. There's a mini language of field tags, and you can read the Go spec to see what you can do here. And this is our hint to the JSON decoder and also encoder saying that this user ID should be coming from user underscore ID. And when you marshal it, it should come out as user underscore ID and not as user ID in capital cases. And when you run that, you see now that the user ID is being filled up with the right value that we have. Okay, and usually most of the IDEs have like a shortcut or a keystroke or something that is going to fill the structs with JSON tags automatically. VS Code does that, Golang does it, even my Vim does it, so you know that it can be done. And it's usually a good practice because even if you don't really care about incoming data, when it goes out, it looks like user ID with a capital U. And for someone who's looking at JSON, it looks funny. What can I say? Okay. So one of the biggest issues we have is known as missing versus zero values. And the thing is that we said that Go is initializing everything in a struct to zero value. So let's say I have a request to start a virtual machine. And it says what image to use and how many VMs I want to run. And we say that if the user did not send us a count, we just need to start a single machine. Okay, so I'm getting a data, and this data is missing the count, right? It has only the image. And when I'm going to run it, I'm going to see that I'm having an image, which is the Debian Bookworks name, which is great, and the count is 0. And now I'm facing a question. How do I know if the user didn't send me count, and then I should default to 1, or they send 0, and then it should be actually an error. They can't send me a 0 VMs to start. Right? There's a distinction between not sending me a count and sending me a count which is 0 or less than 0. So there are 3 ways to solve that. Now, there's a question about converting JSON into a struct dynamically. I don't understand what do you mean by dynamically. Struct is a struct. There's no way to create a specific struct. But if you don't know the type of the message, you can use a map from string to any, and then anything goes inside. Okay, so solution for the missing versus 0 values. The first solution, so I'll show you 3 solutions. The last one is the one I use. The first one is the one I prefer not to use, and this is by using pointers. Right, so if I'm going to use a pointer, now I can check on line 25 here, you see that count is nil or not nil. And if it's nil, it means that I didn't get any value. So if you're using pointers, this enables you to know if something came on over the wire or not, but you introduce another problem, which is pointers, right? So now if I want to check if the count is less than 1, I actually need to do a star before that to make sure that it is there. I have maybe trying to access nil pointers at some point, which cannot be fun. So when I'm running this one, you see now that the count is 1 because I actually found out that the user didn't send it and they moved. So You can use it in your API layer. You need to be really careful about that. And this is another example why you shouldn't share the same start VM struct in the API layer and the business layer. If the business layer has the same struct with the count as a pointer, this is going to have a lot of ifs inside and make it really annoying to work with and also unsafe. So you can at runtime try to accept something. This is not great. The second solution is to use maps. So here now you see what I'm doing is I'm using a map from string to any instead of a struct. And now when I'm using a map to string to any, I know the keys of the map. So I can know if this key exists in a map or not. And now I can check, right? If count is not in the map, I'm going to set it up. And know that I need to set it up as 1.0 and not 1 because this is any. I don't give any hint to encoding JSON what kind of number I'm expecting. So it's always going to be a floating point number, right? I can also check if they sent the image or not, if I'm doing this check as well. And then when I want to work with the count, I need to actually convert it, right? Because count itself is any. I need to do type assertion, right? This is known as a type assertion. Type assertion can come in two flavors. One with only single variable on the left, and then if it's not float 64, it's going to panic. And the second one is the way I'm using it with comma OK, and then the OK is going to tell us if it's actually float 64, if the type assertion succeeded or not. And then finally, if count is less than 1, I can issue an error, and then I get the request with the image, and I need to convert now the count because I can't start half a VM, right? So I need to convert it to an integer and run it. All right, and this is again going to say that I have 1. And you saw that this gives you the option to know exactly which keys were going over the wire, but you saw that this code is much longer and it is uglier than what you. So this is the second solution, pointers, maps. If you want to work with maps, there is something called a package called map structure. And map structure can work, it does the same way of serialization that we do with JSON, but not from JSON, but from map string to any to a specific struct. So it can ease up some of the pain of working with that, and then you can check just if something is missing or not, and then use a map structure to move the map into a structure. This means that you're actually doing unmarshalling twice on every request. That's another price you need to pay. And solution 3, and this is the one I usually use, is to use default values. And then I'm saying, you know what? I'm going to start a VM, but I'm going to set the count into 1. That is the default. And now I'm going to use unmarshal. And now what's going to happen if the user didn't send any count? It's going to stay 1. Because, as I said, the encoding JSON, if there is a field in the struct, but there's no matching field in the JSON document, it's not going to touch it. If the user did send the count, it is going to override the one that I sent with the value that the user actually sent. And now I can actually check if the request is less than 1. It means that the user actually sent something, which is bad. If you run it again, we see that we get count of 1 because this is the default and the data does not have anything. All right. Another thing we can talk about is, I call it avoiding type pollution. So there is a site called Stock Tweets where stock traders are tweeting about which stocks they're buying and selling. And when you ask for example on Apple, you're going to get about 1,600 lines of a JSON document with the message. And inside the message, they're saying that what are other symbols. So someone said, I bought Apple and also Nvidia and also IBM. So the symbols are going to be the Apple one and then Nvidia and maybe the IBM in the symbols. And I want to parse that JSON message. And if you try to mimic the whole JSON message in structs, you're going to have a lot of types. There's going to be a type message and a type symbol, and there are many, many other things inside. But here you can take the advantage that encoding JSON ignores what it doesn't know and say, I just need to model part of that, and I'm not going to model anything. And another thing you can do is you can actually use anonymous structure. So here's the start. We just say this is the URL template, and we are doing an HTTP request to get the JSON from there. And now we get to the interesting part about decoding. So this is everything I need to decode the data that is interesting to me. I'm using a reply struct, which is an anonymous structure. So I don't add another type for message, another type for symbols, another type for symbol, etc., etc. So I don't have this type pollution of defining a lot of types just to pass on JSON. I can use it inside the function. It's not even visible outside. And I'm naming the names in ways that are matching the JSON document. So I don't even need the field tags to say what I need. Right, and then I just can do a decode on the reply, and that's it. Way less code than um, what we have there. And then finally, I can do some calculation. So what I'm doing is I'm creating the related symbols and counting how many times each symbol was shown, right? And if I'm going to run that, you see that all of these were mentioned next to Apple. Probably this one the most, SPY, that's the S&P. But also, and this is the Dow Jones, the QQQ. But all the rest of them, Google and uh, I don't know what the rest of them are. Nvidia, I know. Yeah. All right. So really use the fact that encoding JSON ignores unknown members in the JSON and use anonymous structures. And then when you're parsing things, this is really small and really tight and really working nicely. You don't have to define a lot of things again and again and again. Custom serialization. So we talked about that if you have a struct like this, so I'm going to define something which is a value, has a unit and then an amount. And the unit can be either a meter or I had a meter in inches. Why not centimeters in inches? I don't know, but let's go with that. And if I'm going just to run it, so right, I'm creating a new encoder to the standard output and I'm encoding the value. If I'm going to run it, this is going to look like this, right? The unit, and you see it's in capital U, and then there is the amount, which is 2.1, and this is what we get. But product comes in and says, no. We want it like this in the JSON document. We want it to look different than what you do. And to do that, we have two interfaces that we can implement. So inside encoding the .json, there are two interfaces that are defined there. One is called marshaller, and this is marshal JSON, which you should return a byte slice and a possible error. And then you can also say, coming from a JSON document, I want to handle how it is being serialized to my type. So you can define an unmarshaller interface, which gets a byte slice. Now, this is the raw JSON data. And if it doesn't succeed, it returns an error. So here's the marshalling, right? So 2 steps to do marshalling always. Step 1, convert your type to a type that is known to encoding.json. In this case, I'm converting it to a string, so I'm using sprintf, and I'm doing %f%s, so this is going to be the amount and then the unit, 2.1 meters. Second step is use JSON.marshal to actually convert this data, this type, into JSON. Don't try to construct the JSON manually. There's a lot of edge cases there. Unless you have a really, really good reason for performance, don't do that. Just convert it to a type that is known to JSON and use Marshal. That's it. It will be much simpler and you'll avoid a lot of errors. So you convert that. On the other side of things, we have unmarshaled JSON. Now I want to point something out. You see, this is the receiver V, and this is a value receiver, right? I'm passing in a value. But when you do unmarshalling, we always work with pointer receivers because we just get data and return an error. We're not returning a new value. So we have an existing value and we need to mutate this value. So every time you work with unmarshalling, you always work with pointer receivers. And when we saw the way that unmarshaled works as well, a few slides back, right, we pass in a pointer. So every time we talk about unmarshalling or decoding, always working with pointers. Okay, so when I'm doing an unmarshalling, I need to check. So I'm checking that there's a minimal length to the data. And then I'm creating a bytes.new reader, and I'm using data from 1 to -1 because JSON string is coming surrounded by quotes. So I'm moving the quotes. So now it's going to be only the 2.1 meter without these quotes inside. And now I'm defining two variables, which are the float64 for the amount and the unit for the unit. And I'm using fscanf. And you can solve it with various other things, but this is my way of doing that. You can break it, you can use regular expressions, you can really do it in many, many ways. I found this one to be pretty easy and pretty understandable. Now note that I'm not working on V directly, right? V itself has already an amount, if you see here on these two lines, an amount and a unit. But I'm not doing that. I'm working on two isolated variables because I don't want that maybe the first one succeeded and the second one failed, and then V has some kind of bad state. So I prefer to do the conversion in isolation, and only if it succeeds, then I'm actually assigning it and returning it, right? So fscanf returns two things. It returns how many elements it managed to do, and if there was an error. So in our case, I do not really care about how many elements it considered. I just care about the errors, right? So do yourself a favor, do the move from a string to the actual values, so on the side, not on V, and then only if it manages do that, this is going to work well, and the compiler usually is smart enough to optimize it. So this is marshalling and unmarshalling. And most of the time, custom marshalling is a sign that you are working at the API layer or at the data storage layer. But these types are usually shouldn't go there. If you find yourself that you're doing really sophisticated marshalling and unmarshalling, there's something probably wrong in the way that you're moving between these layers of your code. I don't write a lot of custom marshalling and unmarshalling. Pretty rare. The question, in the case where the user can set the same value as the default value, what is the best way to preserve whether the field was set by the user or default? The only way you can do that is by using a map from string to any, and then you can know which fields are being sent and not. By the way, there's some serialization formats, for example, protocol buffers, they don't even allow you to know that. So when you work with protocol buffers, you have no idea what was sent over the wire. If you use map from string to interface to any, you can actually know that. Um, how to handle unmarshalling into fields of an interface type. You usually work in the abstraction layer, in the serialization layer with concrete types. You don't, it's very rare, and I would say this is an anti-pattern to actually unmarshal to an interface type, right? What encoding JSON is going to do, if you pass it an interface type, it is going to look at the underlying concrete type and fill it in. So from encoding JSON perspective, this is going to work, but this is usually not such a great sign. I'm apologizing for my fall allergies. Okay, the last topic I'm going to talk about is streaming. And we talked about huge JSON objects. Let's say you're saying a query to the database, you're getting 10,000 results or maybe more, and you want to send them to the client. If you want to work in pure JSON, you need to construct one big JSON object which can consume memory. And memory, again, in hosting is money, right? If you need a bigger machine with more memory, you're going to pay more for that machine. If you're going to be able to work with smaller machines, this is going to save you money. So there is no support for streaming in the JSON format. For example, in YAML, you can have several documents in the same place, right? You can do 3 dashes, and then there is support for that. Then YAML can read them one after the other. Don't use YAML. It is very slow in service to service. Really, don't do that. But I'm just giving it as an example of how to do it. So what you can do, the thing is that JSON can be in a compressed format, and then it can take only a single line. Even if you have new lines, even if you have many fields, it can still fit in a single line. So we leverage that fact, and we say that when we stream JSON, we basically send one JSON object per line. Now the other side needs to know that. They need to know that, hey, I'm going to read a line, and this is going to be first JSON object, second line, etc., etc. So this is known, by the way, as JSON lines or some ND JSON or new line delimited JSON. But this is a pretty common practice. And the good news for you is that encoding JSON actually supports multiple JSON objects. What do I mean by that? So let's start with the input. I'm creating a JSON encoder. I have 2 events. One is a click and one is a move event, and the coordinates of where the click was and where did we move the, let's say, the cursor. And now for every range of events, I'm using the same encoder, right? It's not calling a new encoder and then encoding. I'm using the same encoder on this IO writer. And if I'm going to run this, you're going to see that automatically encoding JSON is adding a new line between these 2 JSON objects. I didn't add that, right? It was done by encoding JSON by itself. And now on the other side, this is streaming in, right? So we have an event type, which is a struct with a type X and a Y. And I have this data, right, which is move and a click. And now I'm creating a new decoder on this data, right? And I converted it with strings.newReader. Now it's an iReader, so I can read from it. What I need to do now, when we have streaming, we don't know how many elements are coming in. I have no idea. So I need to do a possible infinite for loop. And in this for loop, I'm going to create this event that I want to decode into it. And I'm going to call decode on that. Now you can move the event outside of the for loop and then potentially remove one allocation, but then you're reusing the same event, meaning if there's stale data, if someone sent, let's say, forgot to send the Y, you're going to get the Y from the previous one. So I prefer to start afresh every time I do deserialization or unmarshalling, but it's up to you. Now, if you get the EOF end of file, this means there's no more data. I'm done. If there's another error, it is an error. And otherwise, I'm going to print out the event. And you see when we run it, I'm actually consuming that. So the encoder and the decoder, both of them are working well with streaming JSON. If you're sending streaming JSON outside and someone is consuming it, let's say from Python, they need to know to read the single line, convert it to JSON, with another single line, convert it to JSON, because the Python JSON library does not know how to handle that. So again, this need to be some kind of a contract between the producer and the consumer. But in Go, if you do it from Go to Go, this is going to work. Now, streaming is really nice, but when you think about HTTP, you send the response body as one big chunk. Well, you don't have to. In HTTP, specifically since HTTP 1.1, we have something known as a chunk encoding. In chunk encoding, the server is telling you, hey, I'm going to send you the transfer encoding header. I'm going to say this is going to be chunks. And then I'm not going to tell you how many bytes are coming out. What I'm going to do is I'm going to send you one chunk after another. And previous to each chunk, I'm going to write how many bytes it's going to be. And then I'm going to write the chunk data, how many bytes, and then an empty line, etc., until the last chunk, which is zero length, and then you know that the data is done. So we can combine that with the way that we saw that the encoder is actually encoding one JSON object per line to send data streaming in HTTP, right? So here's our handler. The handler is going to get some kind of a request. We are going to create what is known as a response controller. Response controller gives us some extra capabilities over this W, the response writer, which are more than just writing and setting the status code. And now I'm creating a new encoder on top of this W. The HP response writer implements IO writer, so I can use the JSON encoder on it. And then for every event I have on, I wrote some query event, I'm going to encode this event here. Now, there is an interesting thing here. You started sending a request, meaning we already set the HTTP status code on the request because we have the status code first and then the data coming in. So if I'm starting sending that, I'm sending 200, okay? And now I have an error encoding. I have no way of notifying the client that in the HTTP protocol itself, I can set it in JSON maybe or something else, but I have no way to tell the client there is some kind of an error. So your best thing is actually to log something. So I'm using the US log package, but just encoding, and I'm returning. But I have no way to go back to the HTTP, first line of the HTTP and say, you know what, actually, there's an internal server. There's no way to do it. And this is streaming. Now, the trick is to do flush after each time you do an encode. Once you do flush, this is actually going to cause it to become a chunked encoding. And now you're going to get one after the other after the other. Now, if I'm going to use a web browser or to see or CURL or something else, I'm going to get the response after it's being already passed. So what I'm going to do is to show you a session with a utility called netcat. Netcat, or the command line is called NC, is working on raw sockets. Okay, so what I'm going to do is I'm going to send an HTTP request. So I'm doing a get. So EOF tells it basically to read from here up to here, right? So this is the first line in the HTTP request. I'm saying get, right? This is the verb. Then slash events, that's the path. And then we are doing HTTP 1.1. The only required header in HTTP request is the host header. This is the only required header. So you can ignore all headers. But I'm also telling the server that once you're done sending the data, please close the connection. And now you see the response that you're sending. So the sender is sending me HTTP 1.1, 200, okay, right? And it says that the transfer encoding is chunked. And now it's telling me, hey, the first chunk is 21 bytes. Here's the chunk. Now there's an empty line. The second one is 20 bytes because move is one letter less than click. Uh, and here's the data. And then an empty line. And then it says 0. This is the no more data is coming. So this is a way for you actually to stream out a huge amount of data, but you need to be aware of HTTP timeouts, right? So you can't stream for an hour. This is not going to work. You probably need something else. But instead of constructing a lot of a really big JSON and consuming a lot of memory, you can say, you know what, I have a megabyte of data to send to you, but I'm not going to use a megabyte of memory. I'm just going to, let's say, one row from the database after another. Maybe each of them is a single K, so you can use a smaller machine and save money for that. All right, so to sum up, we started with serialization in general. We looked at these three mistakes. Then we went to see JSON, and we saw how the types between JSON and Go are being mapped. We saw the API for encoding.json. We discussed the really phony issue of zero versus missing, and I have to tell you, I'm struggling with that in a lot of cases. This is not easy, but I found that the default values work well for me. And then we looked at custom serialization, and finally we looked at streaming that I don't know how much I'm going to use it, but in some cases, especially when I work with the responses from databases that had a lot of small objects, streaming actually saved me a lot of money. That's it. I hope you learned something new. Can you switch to the slides? So I'm going to have a few more webinars. So I'm going to talk about Go for managers. So I'll talk about why using Go, but it's going to be more focused on managers at the high level and benefits of Go and not diving into the language. I'm going to talk about concurrency pattern, right? We have Go routines and channels. We're going to talk about them, see how we're going to use them. We're going to talk about fan out and delayed responses and other things that we use. And we're going to talk about how to get started with generics. Generics is not new, but still not really widely used. So we're going to talk about how we can start with generics and what are the benefits of them. That's it. Thank you very much for spending the time with me, and I hope to see you in the next ones.